Hello friends, welcome back to the bench. Thank you very much for joining me. Now, our patient is a 2007 Subaru Forester Turbo 4-cylinder engine. Very nice machine. Now I got a little sick, so I didn't even turn on the studio lights because they bother me too much, so it's gonna be a little dark. Excuse that. Now the part number in question is AM220. Okay. So first let's see what the customer states. Stopped at a red light. When turned green, I proceeded and the car had no power. I moved along at about 2 to 3 miles an hour. The code P0607. Okay. So that has nothing to do with the ECM. This is obviously a problem of the alternator. Alternator stopped working, and we had a gray out essentially, right? So this is absolutely normal. A car was turned off, restarted, it behaved normally. So intermittent problem with the alternator, very common. A few days later, it started having the low power problem intermittently, and a charge light came on intermittently. Yeah. Mechanic diagnosed faulty or failed alternator. Yes, sir. That is correct. Alternator replaced. Car ran fine for a few trips. So we got a fix. Then the next day, upon starting, it had very rough idle and stalled. After that, I couldn't keep it running. Towed to the mechanic, they diagnosed the lack of fuel pressure and replaced the pump. But they observed the new pump was heating up due to being fed 2-something volts instead of 5 by the PCM. Failed power supply in the ECM? Question mark? No. They traced the failure back to the ECM and had 2 different techs confirm this diagnosis. Also, for the past 6 months, I observed that it idles at the higher than normal RPM for about a minute after a cold start. I mean, that is normal. So, the tech measured 2 volts on the fuel pump instead of 5. Okay, let me show you something. And you can correct me if I'm wrong, because, we're all wrong from time to time. I even told the customer, don't blame the mechanic, because this particular fault is a very, it's not well, maybe it is common, but you kind of have to know about this fault, right? It's not something that the typical mechanic is gonna know. So but fuel pump, okay, fuel pump control unit, signal 1 and 2, right? We have the pins. And signal 1 says it should be 0 or 5 volts. Signal 2 should be 10 to 13. Basically a battery voltage, right? So the mechanic tested this pin and it didn't have 0 or 5. It had 2. So they said, okay, the pump is heating up because it's getting low voltage. It is true that if the pump gets lower voltage, it'll start heating up. Mainly because there's going to be less lubrication and less cooling through the fuel. It's basically going to be grinding essentially, because it's not going to be running at full speed, and yeah, it can heat up because of that. Sure, but what kind of pump would be supplied with 5 volts, right? Have you ever heard of any pumps, fuel pumps that are supplied with 5 volts? Fuel pump typically reaches the power of roughly 100 watts. So that's like 8 amps maybe on 12 volts. On 5 volts, it would have to be more than twice as much, like 20-25 amps, right? So no, obviously the pump is not going to be supplied with 5 volts, so 2 volts over here doesn't mean low voltage, because if you scroll a little a little further. Doesn't take that much effort. It's a sensor output waveform. It's a waveform. So yeah, there's a duty cycle. Because so the pump is constantly supplied on signal 2, which is the power supply, right, for the pump. And this controls the speed of the pump, right? So you want to maintain high pressure of the fuel, although Subarus are known for relatively low fuel pressure. But it's still, you know, if you want to replace the fuel injector or something, you know, if you forget to drop the fuel pressure and you open the fuel rail, you know, don't do that. You're gonna have a bad day. Never happened to me, but you know, it's a decent pressure. I don't remember exactly. It was like 40 psi or something like that, which might seem like high, but compared to like BMWs or Mercedes and stuff like that, they have, you know, 4 times higher fuel pressure. So Subarus are relatively low pressure vehicles. So if you start eating, because this is turbo engine, turbocharged. So as you start eating more fuel, then the pump needs to speed up to increase the pressure, right? So if the pump is faulty, and probably it was faulty, if they diagnosed it with faultiness, you know, if they determined that there was no fuel pressure, I kind of wonder how they did it. But we do have, the ECM has a fuel pressure sensor. Let me just quickly confirm that. It should have fuel pressure sensor. Not every Subaru does. On non-turbo, the output signal is just 12 volts to turn on the pump, and that's it, right? And the pump always runs. But on turbo versions, they regulate the pressure or the speed of the pump. I actually don't see the fuel pressure. We have a fuel tank pressure, or is it manifold absolute pressure sensor? Could be. It could be. So if there is a fuel pressure sensor on the fuel rail, then the ECM is going to give you a code for low fuel pressure, and that's how you would know that the fuel pressure is low. Or you connect to the car and you start the live data monitoring, and you should be able to see that on the can. Sure. I guess the other thing that you could do, if you I mean, how do you drop the fuel pressure? You just remove the fuse, right, for the fuel pump. So, I don't know, maybe they just tested, with the removal, and it behaved the same way, right? I'm not sure. Because once you remove the fuel pump fuse, the car will run for a little while. Well, by a little while, I mean, 10 seconds, 20 seconds, maybe even a minute. And it runs because when it runs at low fuel pressure, it runs really, it's got very rough running, right? It's choking, right? So maybe that was the behavior. So they figured, okay, that sounds like the engine is choking, so probably low fuel pressure. Maybe that's how they did it. I don't know. In either case, they replaced the fuel pump. So I guess the car runs fine now, but the fuel pump is heating up, and they detected low voltage, which is correct. Because it is kind of misleading here. I can understand why you got misled by this, because it says 0 or 5. So, you would expect that it's either going to be 0 or it's going to be 5. But, that's why they tell you over here that it's an output waveform, right? It's a duty cycle. So, yeah, I agree that the service manual is a little misleading. Anyways, what is wrong with the ECM? Can anybody tell me? Can anybody tell me what can potentially be wrong with this ECM, causing intermittent failures? Anybody? If you're a long time viewer, you know exactly what it is. And that's what we're gonna do. So we're just gonna do the IC608 job on it, and all the other problems should go away. Now, heating pump, there's nothing I can do with that. I would think that perhaps the pump is faulty. I don't know if they replaced it with a new OEM pump or new aftermarket pump or just used OEM. In either case, I would suspect that perhaps the pump is faulty. They weren't very specific regarding like what's the temperature of the pump. Is it overheating by 1 degree, 5 degrees, 50 degrees? I don't know. That would tell us something as well. But we only know that the pump is overheating and the voltage is low. Well, anyways, let's do it quickly because I think I should go back to bed and just kind of... I think it's because, you know, I spent last few days in a really cold garage mixing flux, and that's probably what got me. It's very unfortunate that we got early winter essentially. Typically December here is usually still relatively warm, but this December is crazy. Now, since we're gonna be doing this boring thing, let's discuss some feedback that I got regarding our battery on a diagnostic device. Now it looks like that I wasn't wrong per se in my assumptions, but my knowledge was not complete, so I'm gonna have to update the knowledge. But one thing that I've learned regarding this is that, yeah, I was right about those 2 bytes, I was right about the challenge, but it all depends on the chip, right? So it all depends on the battery. So older batteries will have those 2 bytes challenge. The other batteries will have 2 byte key. But the big chunk that ran on BQ, what was it, 40? Or one of the BQ chips, right? Those little newer ones. They have a password, but it's not a 2 byte long password. It is 4 byte long. 4 byte long password. Oh, what happened here? That's not good. Okay. Yeah, my last batch sucks. So 32 bits of data, that gives us roughly a little over 2 billion combinations. So with 2 bytes, yeah, that's say 70,000, less than 70,000. But with 4 bytes, that is over 2 billion. So to crack the password, you would have to spend, I don't remember, I was doing calculations last night just for fun, figuring out those numbers, but it was something around like 18 years or something like that. So a bit long. You don't want to spend 18 years cracking one device, right? In addition, the majority of BQ chips, they will introduce throttling, and they will introduce lockup if you try too many times the wrong combination, right? So basically you locked up the device and you can only unlock it with the password, which is essentially the same thing. So that is a little bit of a problem, but for that one I do have a solution. 2 billion combinations might sound like a lot, but it's actually not that much if you approach it as a distributed architecture, right? So if you have a device, say, you know, just any battery, right? And you don't know the password. We have 2 billion combinations, so we slice those 2 billion combinations into small chunks. say, I don't know, 10, 20, 50, 100 combinations, doesn't really matter. And, you know, each user can test however many chunks they want, right? So say you run 10 combinations, right? Much. Which means if you scale it that way, you know, you can break, and you know, with reasonable assumptions and reasonable number of people, say around 8,000, you can break it in a week, no problem. So it is still doable, right? Password is still doable. You can also do it yourself if you have 1,000 batteries, right? And you just run it locally, right, on 1,000 batteries. That also would allow you to, with 1,000 batteries, a few days. It would take you a few days to crack it. But there is also a higher level of security, and right now I'm not sure about this, and so a lot of this is my assumption. But you have two levels of security, right? You have the security level you need to unseal the battery is the lower one. It's relatively low, right? So you only need that password to unseal it or solve a challenge, which is just 2 bytes long. So that can be done, no problem. But higher level of security is where you still get a challenge, but the challenge is actually solved cryptographically using hash algorithm. And that is not something that we can brute force. There's just too many combinations, and even regardless of how large it is, you know, even if it's only 32 bits, 4 bytes, it's still way too much. Because, you know, hashing algorithms, if in case you don't know, so you're in the loop, hashing algorithm is essentially a scrambler, right? As opposed to encryption, which, you know, you have a key and you encrypt something, so it's encrypted, and if you have a key, you can decrypt it. And hashing works only in one way. But the main property of a hashing algorithm is that it will always produce the same result if you use the same salt or key or seed, the seed phrase or whatever, right? Something that makes it behave in, you know, that makes it different, right? So it's essentially a kind of a key, but if you hash it with that key, it will always produce the same result, but you cannot figure out what the hashed value was, right? And this is something we use on the backend for the password storing, right? We don't want to know your password. We just want to confirm that you know the password. So when you create an account, you create a password, we create a hash from that password, and we store it as a hash. So even if you steal the data from the database, you don't get the password in plain text. And then when you log in, you type in that password, so we run hash on it again, and if the hash matches, that means you know the password. But we don't know the password, because we don't need it. Which means the level of security here is staggering, right? So the chip sends you a challenge, and you have to hash it and send that hash back to the chip, and the chip does the same, and if the hashes match, you have access. That, however, as far as I know so far, is only for a you know, things like actually, you know, changing the properties of the battery, right? If you want to override the voltage, manufacturer, or what have you, right? Things that you don't want to do, we don't want to do, we don't need it for anything, or to dump the flash, right? So we can essentially dump the compiled code from the device in hopes to, you know, to crack it, to reverse engineer it. right? Then maybe to flash it again, that kind of stuff. So we don't need that. So if that be the case, I don't think we're gonna need it, right? I don't think that's gonna be a problem as long as the unseal is still just, I don't know, 32-bit value, 32-bit password essentially. We should be good. But if the newer devices actually require hash algorithm, right? Well, that kinda is a relatively big problem, because that's not something that I can just, you know, crack, right? The understanding of the problem means nothing if you can't solve it. So we'll see about that. Also, a lot of you guys, well, maybe not a lot, but some of you guys are not happy with the protection, right? You want to unlock any battery you want to unlock, and even if it explodes, you don't care. Well, come on, chip. Okay. We'll see. We're still kind of debating. There's, you know, more and more people are joining the project. You know, even if we don't make it open source, there's enough people that I'm sure it's gonna leak enough that you're gonna be able to find a, you know, cracked version of it. So you don't have to worry about that. And we're getting more and more people every day. That's, well, some want to contribute by you know, testing, right? And some want to do coding. Some people send like documentation and stuff like that. So, you know, all of that is very useful. So we'll see. I mean, we're building it. We're doing it. I said we were doing it. We're doing it. You know, regardless of what the result is going to be, we're gonna make it. But as I said in the previous video, you know, it could be that, you know, only a select few batteries will be able to, the tool will be able to unlock, or there's just not going to be an unlocking feature at all. You know, it's possible. So, you know, don't get your hopes up too much. But I also I got a lot of ideas from the comments, right? And I do have an idea of taking a little shortcut developing. So if I'm really motivated, meaning if I really want to get it done, I know how to get it done. I know how to take a little shortcut. But I want to avoid that. But it's definitely an option. So in either case, we are capable of actually getting that done. And that's what we are trying to do, and that's what we will do eventually. Yeah, I probably should have made like a list of stuff that you guys said, the feedback and stuff, but I'm really not feeling well, so you're gonna have to understand that. Okay, I think so the problem with my latest batch is I'm pretty sure that the main issue was just that I know what I did wrong, essentially. But it looks like, I mean, it works, as you can see, it works, but I used it yesterday, right? And today I tried to squeeze it out and it clogged the needle, right? That means too much alcohol in the solution. That's why it's so runny and stuff. I can save that by just basically removing it from the syringes and dehydrating it a little more and pouring it again. Can be done, but I'm just gonna start a new batch because it felt like it was a little bit too runny, but I also changed the formula a little bit. So yeah, so we're gonna call this one a failure. It unfortunately happens. That's why if you're waiting for your flux and it seems like it's not coming ever, it's coming, it will come. Just be patient, because stuff like this happens. Sometimes I just mess up. I'm also a human. Okay, poor lighting, but what am I gonna do? I get all the flags. Okay, the bottom. Alrighty, that should do it. I think this is going to solve your problem, but if it doesn't, definitely let me know. Also, so things that I read you guys over here, we also exchanged like crapload of emails regarding this case. So, you know, all that conclusion from my side is not only based on this one piece of paper, it's also based on email communication and a lot of other information, so just so you know. Alrighty, this should do. Thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.